Today, let us look into the first problem on next problem on this pure bending equation. So consider this problem: a cantilever of length 2 meter fails when a load of 2 kilonewton is applied at the free end. So I am having a cantilever beam like this. And a 2 kilonewton load is applied at the free end. It is failing. That means when a 2 kilonewton load is applied, it is failing. And the length of the cantilever is 2 meters. Length of the cantilever is 2 meter. And what are things are given? If the section of the beam, that is a beam is having a section of, so this is a beam, the beam is having a 40 into 60. So 40 means it is breadth and depth is 60. Always take the larger portion as the depth. Okay. Find the stress. I have to find out the stress. So here it is not given, since it is given only the stress, that it means we have to find the bending stress. Okay. So I am given a load, then I am given it is failing at 2 kilonewton and the section is given. So this can be done. First one, you have to write the bending equation. So what is the bending equation? I know that M by I is equal to F by Y is equal to E by R. This is my equation. From this, which is the term which I have to find out? So here I have to find out the stress. Stress means F. So here F is the unknown. So either I can take these two terms or M by I, etc. Anything I can take. So since here E, Young's modulus is not given, R is not given, so I am going to take these two terms. Okay, these two terms I am going to, that is M by I is equal to F by Y. So first one, in that what all terms I need? F is, I have to find out, M and I and Y. M is the moment. So that's a maximum moment. I have to find out the M is a maximum moment. So maximum moment M. So where will be the maximum moment happening? For a cantilever beam, the maximum moment will happen at the fixed end. At this point, the maximum moment will happen. So how can I find out the moment at that point? Momentum means force into perpendicular distance. Perpendicular distance means this is the perpendicular distance. So it will be rotating like this. So the distance is 2 meters. So momentum will be 2 kilonewton into 2. That will be 4 kilonewton. Okay, 4 kilonewton meter. This is my moment. M I got. Next one, I am having I. What is the I? I is a rectangle only. So rectangle, if this is B and this is D, then so here I is the moment of inertia. So moment of inertia is taken about the axis, that is about the centroidal axis. So for a rectangle, the moment of inertia will be given as B dq by 12. Now that is I. What is Y? Y is the Y or Y max. It is the distance of the extreme fiber from neutral axis. So this is the neutral axis. I will be drawing a larger figure. So this is the neutral axis. So Y means, since this Y can be this one or Y can be this one, top or bottom distance. Since it is a symmetric figure, so this total distance is 60. Therefore, what will be this distance? That is 30 and 30. Therefore, since this, let them taking Y1 and Y2. So Y means it is the distance of the extreme fiber. Extreme fiber means the edge. You can consider it as the edge. So this is one edge. This is another edge. So which is the so in this, which one is the highest? That value we have to take. So since it is a symmetric figure and it's a rectangle, now Y max is 30. Okay, or 30 I can take, or it can be what is it is D by 2. Y max is equal to, it is total is D, that is D by 2. So how can I can rearrange this equation as I have to find F. F is equal to, or I am writing rearranging, that is M is equal to F into I by Y. Now What is I by Y? This is Z. So M is equal to F into Z. So in this, what I have to find? F. F is equal to M by Z. M I have found out, that is 4 kilonewton meter. Now Z. Z is equal to I by Y. So here I am finding Z. Z is equal to I by Y. So I by Y, that is B d cube by 12 by d by 2. Since it is the next problem only, I am explaining a little bit more. So it will be, you can simplify, it will be getting B d square by 6. Okay, B d square by 6. Now you can look in this here what is written, that is Z is equal to B d square by 6. So B is 40, D is 60, this is 40, this is 60, divided by that is, we will be getting this much value. Unit also you have to be clear. Now instead of F here in the note it is written as sigma only. So you can write any value. Instead of sigma can be written F. Everything will be the same only. Okay. So no need to be having any doubt in that. So here we are finding out the maximum stress. Why it is given maximum stress? Here it is maximum is written because in the question it was given that here while applying a 2 kilonewton load, the cantilever fails. Since this is failing, so we will be finding out the maximum. So that is the reason why it is written as maximum. So F max is equal to, so here I substituting Z is there, then M I have got as 4 kilonewton meter. So I can convert into Newton meter. Okay, I am converting. So 4 into 1000 into meter into millimeter, that is again 1000. That is, it is 10 raised to 6. It is written. So by substituting, I can find out this is my maximum stress, or the bending stress will be 166.67 Newton per mm square. So from the simple equation only we have done this. Okay, let us look into another problem. So here, calculate the maximum stress induced in a cast iron pipe of external diameter 40 and internal diameter 20 and of a length 4 meter when the pipe is supported at its ends. Okay, so the pipe is supported at its ends. It carries a point load of 80 kilonewton at this center. So let us just expand that problem. So here, what is given? That is, here we are having a cast iron pipe. So a pipe is there and it is supported at the ends. So that means what will be the support? This is a cast iron pipe and it is supported at this ends. That is, here and here there are two supports. So that means it is a simply supported only. That is the meaning. Since no other, there are a lot of types of supports, but since it is simply no other specifications is given, we can take it as a simply supported. So a cast iron pipe is there and it is supported having a length. The length is given as 4 meters. Okay, length is given as 4 meters. And what are the conditions given? Here we are having a diameter of 40 and an internal diameter. So it is having the cast iron pipe. If I am drawing a cross section, it will be like this. So it is having, since the pipe it is hollow only, and the diameter is given as it is 40 and the internal diameter as 20. If I am drawing the cross section, how it will be like this? It will be like this only. Okay, so this will be my pipe, cast iron pipe. And what are the other details given? It is supported, carries a load of 80 Newton. 80 Newton is carrying at the center. So at a distance of 2 meters. 80 Newton only. Okay. You have to be clear that where is this Newton or kilonewton. So here the figure is again drawn in the figure itself. So what we have to find? Calculate the maximum stress. I have to find out the maximum stress. So first thing is that I am writing what all the details are given. So here the stress is given. F is equal to, I have to find F. So what is the equation I am having? M by I is equal to, again it will be equal to F by Y. So again I can write that M is equal to F into I by Y. Okay, and what is I by Y? That is F into Z. So again now here I am taking, what is Z? Z is equal to I by Y max. I means for a circular section, which is a hollow circular section only. So what will be my I? Pi by 64 into capital D raised to 4 minus small d raised to 4 divided by, what is Y max? This is my neutral axis. And if anybody is having any doubts, you can ask. And Y max is the distance of the extreme fiber. This is an extreme fiber. This is also an extreme fiber. Since it is a symmetric figure, this and this distance, both distance will be same. That will be the Y max. So what will be the value of Y max? Total is D. Okay, and this small distance is small d. So the total that will be D by 2. So this will be my Z. So here all the details are given. Capital D is given as 40. Small d is given as 20. So 40, and here small d is given as 20. So substituting this, we can find Z. So okay, now Z is found out. Now again I have to find F. F is equal to M by Z. Now next is M, moment. Okay, that is moment. So how can I find out the moment here? Here it is given as, so this is the figure. So I am just simplifying. I am just drawing a line diagram. So here a beam is there, and the beam is 4 meter long. It is having a load of 80 Newton at the center. So this is our condition. So the moment means it is the maximum moment. So 3 values you have to by heart. You have to understand, or we can find also. That is, what are the values? That is, this I have explained earlier itself. If a cantilever is having like this, a load is here, the maximum bending moment will be, if it is L, what will be the value? W L by 2. Again, if a UDL is there of W, the maximum bending moment will be, if it is L, it will be W L square by 2. Another value you have to understand is that if I am having a, okay, so if I am having a simply supported beam which is having a central load like this W, and it is acting at the center, the maximum bending moment will be W L by 4. And another thing you have to understand is that if I am an UDL is there, maximum will be W L square by 8. And the final one more you have to understand, if a W is acting, here it is A distance, here it is B distance, the value will be W AB by L. So these are the values you just have to understand. Else also we can find the values. That is, how can I find out this? Here the maximum bending moment. How can I find out the maximum bending moment here? First on, I will be able to find out the reactions. Here what will be the reaction? Here it will be symmetric. So here will be 80, 40 and 40 will be coming. So maximum bending moment will be at the center because it is a symmetric diagram only. The next problem, another condition will be there. So the maximum bending moment will be at this point. So from this point, how can I find out the bending moment? Either I can take the distance to the moment to the left or to the right. So if I am taking to the right, what will be the value? Here I am taking the bending moment will be, bending moment at the center will be 40 into, perpendicular distance is 2. 40 into 2. That is 80. Again, the same equation I am using here. What is the equation? WL by 4. If I am using that also, I will be getting the same value only. So that is the reason why I have told that you just have to WL by 4. That is, W is 80. 80 into 4 is, total is 4. 4 by 4. That is, again I am getting 80. So both the values are same. So this is my answer. That is, the maximum bending moment will be 80. And what is the unit? 80 Newton meter. The unit should be clear. Okay. So we have obtained. So now we can look this figure. So here the bending moment we have found that that's 80 Newton meter. Now I have, since the value of the I etc. is in millimeter, so it is better to convert this Newton meter to Newton millimeter. So it is multiplied into 10 raised to 80 Newton meter. Again it is converted to Newton millimeter. How? 80 into 10 raised to 3 Newton millimeter, or 8 into 10 raised to 4 Newton millimeter. That is the reason it is written like this. Okay. Now coming into, so I here it is found out I have explained directly Z we can find out. Now by substituting everything we will be finding what is the value of F or sigma. So this will be the value of the maximum bending moment. This is the value of the maximum maximum bending stress. Okay. Now similarly, let us look into another question. Okay, a small here some more complicated question is there, not a complicated one. Anyway, just understand, a timber beam is given. A timber beam of rectangular section 8 meter is simply supported. Okay, it carries a UDL of 12 kilonewton per meter over the entire length. Then a point load of 10 kilonewton is acting at a 3 meter from the left support. 3 meter from the left support. If the depth is 2 times the width, and the stress in the timber is not exceed 8 Newton per mm square, find out the suitable dimension. So here what is the thing I have to find? I have to find out the dimension. That is, here I am giving, here the stress is given, then the other loading is given. I have to find out the dimension. Okay, so let us take this one. So here what is given? I am having a timber beam of 8 meter length. It is simply supported. So that means this is a beam, this is simply supported, and the distance is 8 meters. Okay, and it is having a load of 12 kilonewton meter, and UDL is there. So let me draw the load. Load is drawn in the red color, and UDL is there. Okay, what is this value? That value is 12 kilonewton. Value is 12 kilonewton per meter, and also a point load of 10 kilonewton. What is given? A point load of 10 kilonewton at a 3 meter from the left support. Which is a left support? This is a left support. From here, a 10 kilonewton is acting. A 10 kilonewton is acting at a distance of, what is the distance? The distance is 3 meter from the left support. So this is our condition. So I have drawn the condition. Now what are the things given? I have to find out the dimension. So just I am assuming the dimension of this beam as, let it be B, and this is D. Now what are the conditions that are given? Here the depth is 2 times the width. Depth is 2 times the width. This is one condition. Then what is given? The stress in the timber is not exceed 8 Newton per mm square. That is, F is given. Our bending stress is given. What is that? 8 Newton per mm square. So we have to find out the depth. So what are the conditions we are having? So first of all, we can write the bending equation. What is the bending equation? M by I is equal to F by Y. This is the bending equation. So from this, which is the term that is relating to these two? That is I and Y. So since the load is given, I can find out M. M is the maximum bending moment. So M I can find out M. F is given. I and Y. So this can be written as F into I by Y. That is, what is F into I by Y? That is Z. So for a rectangle section, what is Z? BD square by 6. So it is found out using that is I is equal to BDQ by 12, Y is equal to D by 2. So simplifying, BD square by 6. So here from this either I can substitute instead of D, I can substitute 2B. So likewise I will be getting, so I am substituting b into 2b the whole square divided by 6. So Z can be written as b cube by 4 by 3, that will be 2 by 3. So this will be my Z. Okay, this will be my Z. Now, so from this, if I am substituting this in this value in this equation, I can find out b. Now next thing, this problem is made some more lengthy. That is, I have to find out the maximum bending moment. Okay, so this is my diagram given. I have to find out the maximum bending moment. Okay, so here so here I have to find out the maximum bending moment. So I am taking the points as A, B, C. So how can I find out the maximum bending moment? So okay, so in order to find out the maximum shear force, first out we have to draw the shear force diagram. Okay, so the shear force diagram will be like this. So how I am drawing? First one, I will be finding out RA and RB. So RA it will be 54.25 and RB will be 51.2. It is written in the note. Now using the equilibrium equation. Now the shear force 54.25 here I have drawn. Then in order to find out the shear force to the at the point C, there will be two shear forces. Since there is a load, therefore I consider a section to the just to the right and left hand side, another section just to the right hand side of C. So by considering the forces to the left, that is 54.25 minus that is 54,250, that is in Newton. I am just saying in kilonewton only, minus 12 kilonewton into 3, that is 18.25. So this is the point. Now again 18 minus 10, that is 8.45. And in the at this B, the shear force is 51.75. So I can draw the shear force diagram like this. And from the shear force diagram, it is clear that between the portions C, B, here, between the portion C, B, there is the change in shear force. So what from that? How can so this is the point where the shear force the bending moment will be maximum. Okay, so this is the point. So first thing is that I have to find out the point. Where is that point? So I am just taking, let the point be at a distance x from this direction. So in order to find the shear force at x, the shear force at x will be 0. So what will be the shear force? I will be taking the forces to the right or left, you can take. Since I have taken the distance from this right only, so I am taking to the right. What are the forces? RB is there. RB minus, what is this? 12. 12 into x. This is equal to 0. RB we know that it is 51.75 minus 12 into x. By substituting this, x is equal to 4.3125. So at a distance of 4.3125, the shear force is 0. Okay, so once again I can draw the figure, that is so this is the given beam and the loading conditions are given like this. Okay, this distance is 3, this distance is 8, and we have found out that the shear force is 0 at a distance of 4.3125 meter. Now since it is 0 at this point, therefore the bending moment will be maximum at this point. Okay, so bending moment will be maximum at a distance of 4.3125. So again now I have to find out the bending moment. Okay, now the bending moment can be found out. Either I can take the forces to the right or I can take the forces to the left. Right and left I am taking. So either I can take to the right, both the values will be the same. So since so you have to choose. Let us choose to the left. Left, what all forces are there? Here one force is there, here one force is there, and 3 forces are there. But to the left, right, what are the forces? Only 2. This one and this one only. Therefore, bending moment. How can I take the bending moment? The bending moment will be, this is RB. So, RB into, it will be rotating to the clockwise. That is, RB into, what is this distance? 4.3125. 4.3125. Then this UDL is 12 kilonewton per meter. So, minus 12 into load, first I have to write 4.3125 into. So, let me write more clearly. That is, I am going to find out the bending moment at this point. So, bending moment is equal to maximum bending moment. That is the maximum bending moment. RB into 4.3125 minus, this is a UDL. This UDL is the first one. It has to be converted into load. The load will be 12 into distance. 12 into 4.3125. And where that will be acting? It will be acting at the center. That is, this into 4.3125 divided by 2. So, this will be my moment. So, here it is found out. Here you can see that same thing only written here. The maximum bending moment is equal to RB into 4.325 minus same thing. So, I will be getting the bending moment as this one. A larger value is got. That is 111,585.93 into 1000 Newton mm. If I can simplify this also, I am simplifying this. 1.11 into 10 raised to 8 Newton millimeter. Okay, you can write in that way also. The same only. 1.11 into 10 raised to 8 Newton millimeter. Okay, so now I have found out M. Now we are having M is equal to F into Z. M is equal to F into Z. Now M I am having, F is given in the question. F is given as 8. It is given as 8. Z, again, Z we have found out. Z is equal to B d cube by B d square by 6. And we know that D is equal to 2 times B. By substituting this, we will be getting, first we can find out B. B is equal to, I am getting B as this one. B cube as 20.923 into 10 raised to 6. Here you can take the cube root. It will be 275. And what will be D? D will be 2 times of that. That will be 551 mm. So, by this way we have found out the dimension of the beam. So, our beam is having a depth of 551 mm and a width of 275.5 mm. So, with this dimension beam, it will be safe to carry the load. So, in many cases, while we are designing some beams, for example, if you are going to renovate a building, and while renovating a building, we will be having all the data. That is what will be the maximum stress. That is, for example, the present beam is not having that much capacity and it is deflecting. And in order to reduce that deflection, I have to provide some other material to take up the load. So, for example, if I am using a steel beam, I can know what is the maximum stress it can carry. So, from that, by this type of calculation, I can find out the load. From that calculation and all, we can find out what dimension it is needed. Okay, so in the practical way, in order to, it is mainly known as retrofitting and all. So, if I am having an old building, if I have to increase its capacity, I have to provide some extra beams. Okay, for example, we will be using some steel beams and all. So, by this calculation, we can find out what dimension of that steel beam should be provided in order to carry the load. Okay, that is a practical application of these type of questions. Okay, so these are the ways in which we can find out this load. Now some more questions are given in the note, so you just there is not much differences. The basic thing you have to understand is that that means we will be having the bending equation. So the first write the bending equation. Bending equation is m by I is equal to f by y is equal to E by R. Okay, E by R. So from that, what are the data given? You can use either these two equations or we can use the other two equations. Likewise, we can find out different. So this type of problem will be coming in your competitive exams also. So in many competitive exams, like in your GATE or in your any PSC, Kerala PSC or examinations, or your staff selection commission examinations, direct questions will be asked. So the best thing is that you have to understand, first thing is that you have to identify from which portion the question is coming. Then only we can substitute in this equations and find out the values. Okay, so m by I is equal to f by y is equal to E by M. So first thing is to identify the question, and next is to find out what will be the answer. Okay. Okay, so that will be the with this we will be completing the first half of our module 4. Okay, so now we have studied about the bending stress. Okay, so in any beam, I have already said that, so in any beam, that is, if I am having a beam like this and a loading is there, then it will be bending like this, it will be having a bending moment, it will be having shear force. Now we have only considered the bending moment and the corresponding stress. Now we have to find out the shear stress. Shear stress will be due to the shear force. So the next topic is the shear stress. Okay, so shear stress in the beams. So next one we have to find out the shear stress. That is, so whenever we are loading a beam, there will be bending moment and there will be shear force, and due to that shear force a stress will be developed, and that is known as shear stress. Okay, so the shear stress is given by the equation. This is the equation for shear stress. Tau is equal to F into F into A into y bar by I into B. Okay, that is, just consider a section like this, a rectangle section like this. Okay, a rectangle section is here. Here, F is the shear force. So the shear stress can be found out at any layer. I can find out the shear stress at this point. I can find out the shear stress at this point. Or I can find out the shear stress at the neutral axis. Any point I can find out the shear stress. So shear stress at a point, I am considering this neutral axis. Shear stress at this neutral axis is given by this equation. F into A into y bar by F is the shear force. A is the area of the section above the that is area of the section above the neutral axis. That is, if I am finding the shear stress at this point neutral axis, then the area will be this one. If this is B and this is D, so what will be the area? Area will be B into D by 2, this area. Okay, then y bar is the centroid, distance of the centroid from the neutral axis. That is, this is the area. So the centroid will be at this point. Okay, this is D by 2. Where will be the centroid of this area? That is D by 4. I will draw another figure also, so it will be clear. That is, if I am going to find out the shear stress at this point AB. Okay, AB. Let the distances be this be D and this be B, and this distance be something like 1 or 1.5. Okay, I am just taking a distance. If I have to find out the shear force at this toe AB, then what will be the area? First one is F is the shear force. Shear force we can find out. Last time we have found out this last equation also we have found out. Same way only. Area is, this area will be like this. This will be the area. Okay. This will be the area. And so area will be, what will be the area? Area will be B into 1.5. Then what is y bar? Y bar means it is the centroid distance of this area. Where will be the centroid? It will be at this center. Okay. This centroid to this area. This to the neutral axis. So this is y bar. So here the y bar is directly, here the value of the y bar is directly d by 2 only. But what will be the y bar here? This total is d by 2. Okay. And this is 1.5. So it will be half of 1.5, that is 0.75. So this will be at a distance of 0.75. So what will be y bar? It will be d by 2 minus 0.75. This distance. This will be y bar. So for any area, for any portion, area above it should be considered. Okay. That is F A into y bar. What is I? I again, it is the same only, moment of inertia. That is the moment of inertia about the neutral axis. Then B. B is the width of the section. Width means here it will be same. B only. Okay. While we are finding out some section like for example, okay, I will explain that. So here, so this is the meaning of this equation. So the shear stress is given by the equation tau is equal to F into A into y bar divided by I into B. Okay, where F is the shear force, A is the area, Y bar is the distance of the centroid from the neutral axis, I is the moment of inertia, B is the width of the section. Okay. So where the B will be changing, we will be explaining while doing some problem. Okay. Now the variation, what will be the variation of the shear stress is given here. So for a rectangle section, the shear stress distribution will be like this. So this is a parabolic variation. This is obtained from this equation only. Tau is equal to F into A into y bar by I into B. So how we will be drawing? I will be first considering a small section here. Then I will be finding out the tau value. Again I will be finding another section. I will be taking the tau value. Likewise only this is taken. And the maximum tau, it is given by here, by substituting we will be getting this value. It will be 3 by 2 times F into Y. We will be doing this finding out, explaining some more. Just understand for this class, just understand how the variation is coming. Okay. Now again, I will be explaining this in the more in the next class. So just I am giving an idea about what we are studying only. Then I will be showing some variation for some figures. For example, look at this figure. For a triangle, the variation of shear stress will be like this. Then for a diamond section, this is known as a diamond section. Diamond. And the variation is like this. Okay. We can find out this variation by using the equation. Same equation, we can find out the variation. Then for a L section, this will be the variation. Okay. Then for a TI section, this will be the variation of the shear stress. Here we are explaining about the shear stress only. This will be the variation. Then for a T section, it will be like this. We will be doing a I section. Then from that you will be directly able to understand why the variation is happening and what. The next class we will be taking. Then for another section like this, this will be the shear stress variation. Okay. Likewise, this is a cross section, cross shaped. Then there are different type of sections, and the different variations are given here. So these things we will study how we are obtaining these type of variation in the next coming classes. Next class we will be studying about that. So today we have studied about how to find out the how to find out the bending moment, then how to find out the using the bending stress equation, m by I is equal to f by y is equal to e by r. How to find out the various stresses using the pure bending equation. Next thing we have studied the shear stress. I have given an introduction about shear stress and its variation and this equation. So just understand this equation. The next class you just read this equation and then only we will be able to take the next class. Okay. With this we can wind up today's class.